So we're looking at the handshake problem, and I've started setting up my table for solving this. Some of you saw this problem where the hosts were Lucy and Edward. I personally chose to change Edward's name to Jack, and the reason was they invited 4 couples, and I just gave those people names A through H. Edward obviously starts with the letter E. I wanted there to be different variables. So guest A and B are a couple, C and D, E and F, G and H, and then obviously Lucy and Jack are also a couple. Now, Jack asked everybody, he asked 9 different people, the 8 guests and Lucy, whose hands they shook, and he got 9 different answers. So you might be thinking it's possible that somebody shook 9 hands. However, you don't shake hands with people you already know. You don't shake hands with someone who is in your couple pair. So for example, Jack would not shake hands with Lucy because they already know each other. At a maximum, he could shake the hands of 8 other people. So any person could shake 8 hands. However, we're not going to say that Lucy or Jack shook 8 hands, and the reason is going to be clear at the end. So the key here is knowing that if there were 9 different answers, one person would have to shake 0 hands. One would have to shake 1, 2, 3, 4, 5, 6, 7, and 8 hands. There's 9 different answers of how many hands they shook. We're going to start with who would shake 8 hands. Now, this person obviously wouldn't shake their own hand because they're not shaking their hand of themselves, and they wouldn't shake the hand of the person that they're in a couple with because they know that person. So we have to assume that the person who shook 8 hands was the significant other of someone who knew Lucy and or Jack and was invited. We're going to start with person A and think that they shook 8 hands. Not their own hand, not their significant other's hand, but person A could shake the hand of person C, person D, E, F, G, H, and then also Lucy's hand and Jack's hand. So the number of handshakes that person A gave was 8. Now, I already listed that A shook these people's hands, so I can fill those in my table down here. I know that A shook C's hand, so obviously C shook A's hand. I know that A shook D's hand, so obviously D shook A's hand, etc. So I'm going to list that all of my guests shook the hand of person A. Now, going back, I knew that everybody gave a different answer. The person who shook 8 hands was person A. So everybody else shook anywhere from 0 to 7 hands. One person shook 0 hands. The only person in my dinner party right now who still has not shaken anybody's hand is person B. So person B has to be the one who shook 0 hands. So 0 is person B. And now I'm going to consider the person who shook 7 hands. Going down the list, that's person C. We know they shook the hand of person A. They did not shake the hand of person B because person B shook nobody's hand. They didn't shake D because it's their significant other, but everybody else on the list. So C shook hands with E, F, G, H, Lucy, and Jack. And just as I did for person A, I'm just going to fill it in backwards. So C shook hands with person E, which means that person E shook hands with person C. C shook hands with F, so F shook hands with C. Same thing for G, H, Lucy, and Jack. Now, I know that person C shook 1, 2, 3, 4, 5, 6, 7 hands. So the person who shook 7 hands was C. Everybody else shook anywhere from 1 through 6 hands. Can't be A, B, or C. We've already accounted for them. And everyone from E down has shaken at least 2 hands. Therefore, D has to be the only one who shook 1 hand. So my person D shook 1 hand. At this point, a pattern starts to emerge. You might see it. I've accounted for the person who shook 8 hands. I've accounted for the person who shook 7. Now I'm going to think about the person who shook 6, person E. They shook hands with A and C. We know they didn't shake hands with B. We know they didn't shake hands with D. And they're not shaking hands with their date F. So they're going to shake hands with G, H, Lucy, and Jack. So that's 1, 2, 3, 4, 5, 6 people that they shook hands with. The 6 is person E. Again, filling in backwards. E shook hands with G, therefore G shook hands with E. E with H, with Lucy, and with Jack. Again, looking at process of elimination, there has to be somebody who shook 2 hands. We figured out everybody in the top. The only person possible who could shake 2 hands would be person F. They're going to be a 2. The same pattern continues. We accounted for 8, 7, 6. Now we know person G shook 5 hands, A through C above, not H because it's their date, and then Lucy and Jack. So person G was 5. Therefore, person H is the only one who could shake hands with 3 because G shook hands with both Lucy and Jack. So person H shook 3 hands. And then at this point, from Jack's questioning, when he got 9 different answers, the only option left is Lucy for 4. And at the same time, Jack also shook 4 hands. And this right here is the reason why Lucy has to be the one that shook 4 hands, because she's part of the only couple where both people in the couple shook the same number of hands. I hope you enjoyed our handshake problem. Again, no hands were shaken in the making of this problem, and we look forward to doing some more math with you tomorrow.